Hello everyone. In this particular session, we will understand about assembler directives in depth. First, we should know what do you mean by an assembler directive. Okay, do you think it is similar to any other instructions we use in the code? No. Okay, so this particular assembler directive is a command in assembly language which instructs the assembler to perform specific action during assembly, such as reserving memory, defining constants, or organizing code. Okay, but one thing you should know about assembler directive is that they do not generate executable machine instructions. Okay, and these whatever assembler directives that we will learn soon are not executed at runtime. They are only for the assembler in order to control the assembly process. Now, since we know some basics about assembler directives, let's understand each one of them. Whenever you write any assembly code for LPC 2148, the first thing you notice is this particular statement, which is area followed by some name, followed by code, followed by read only. This area is nothing but an assembler directive. When an assembler sees this particular statement, the first thing it does is it defines a named section of memory. What does it mean? As soon as this particular statement is seen by the assembler, it creates a section or area in the memory in order to store whatever content we'll be writing after this particular statement. But then, in order to identify this particular section of memory, we assign some name. This can be any random name. Followed by that, we specify whether this particular section of memory will hold data or instructions, that is nothing but code. So based on that, we will specify the property or attribute of this area as either code or data. In our case it is code because we are writing actual instructions here. And read only here informs that whatever content will be written in this particular memory section should not be modified during runtime. So that is about area. The next thing we notice is import. And you can see here I have made a comment, use a symbol defined in another file. In other words, this is nothing but an assembler directive. Only by using this particular statement we can include a code which is defined in some other file. Okay, in our case calculate sum is nothing but label under which we have certain set of instructions and we have exported it in the other file, that is in the file external.asm. What this export does is it makes sure that this particular code is visible to other files. Import here is used if you want to include any code modules from some other file. Okay, and export is used if you want to make sure that a specific code of this particular file is visible to all the other files. Next we have something called EQU, which is nothing but an assembler directive which defines a constant value or symbolic name. What does it mean? Wherever I use count max, okay, the actual value it represents is 40. So next we have something called entry, which is an assembler directive which marks the starting point of program execution so that the assembler knows from which exact line the execution should start. After entry, whatever label will be specified, that will be the location where your control jumps to when you start debugging. Then I have written ARM here to indicate that the next whatever codes are there, they are written using ARM instruction set and the CPU should execute in ARM execution state. A macro defines a reusable block of code. Macro and end are nothing but assembler directives. In this particular case, I have used a name clear register okay, for this particular macro. So what this will do is, if anywhere in the code you write something like clear register followed by some register name, immediately it will clear the content of that particular register. You can write more complex instructions here and it will get executed when that particular macro is called. Okay, so start is nothing but a label. So here I'm trying to load some data. So let me check what's happening down there. In my read only section itself, I have defined 3 labels, and these 3 labels are associated with data. Okay, what are these data? Very first one is a 32-bit data, where DCD is an assembler directive, which means define double word, and it actually means the values considered here. If you put comma and followed by that, if you write n number of values here, all those will be considered as 32-bit value because of this particular assembler directive. This assembler directive defines a word, which is nothing but defines 16-bit data, and here DCB defines a byte. What it means is that after DCB, all the next values of data you write here are all 8-bit data. Align is again an assembler directive. This ensures that next instruction of data starts at specific memory boundary. The very first data, let's assume, is stored in some memory location 4 and all zeros. The data that is to be stored is, this requires 4 location to be stored. Okay, so the next data, that is DCW data 3456, will be stored in very next location, which will be something like this. Till now there is no error, and next we have a byte of data to be stored, but the problem starts after this. Now I have finished storing this data at an even location, but the next location where data will get stored is 4 all zeros and 7. Is it allowed? No. If data is stored in this particular location, you will get warnings or errors because of memory alignment issue. Because this is an odd location, if data is stored here, accessing it becomes difficult. To make sure the next location from which data is accessed is some location which is word aligned, is a location divisible by 4, we use similar directive called align. This will make sure the very next instruction or next data to be stored gets stored in a location which is word aligned. Fine. Here we have again used assembler directive area, which will define a section in memory. It has a name my data, but the content stored here is actually a data, not instructions, and this section is read write because we should be able to modify this content during runtime. Then we have something called space here. This particular assembler directive reserves uninitialized memory space. That is, if you write 20 here, location required to store 20 bytes of data is reserved, but it is not filled with any data. Okay. Then we have end here, which indicates or which tells the assembler that this is the end of the source file. Now we will continue here. Very first thing that happens is R0 is loaded with the address of byte value. What is byte value? Byte value is this label, okay, which is associated with the 8-bit data 12. Now when I try to execute this instruction, what will happen? Address associated with byte value will be stored in R0. When I execute this instruction, the content, that is 12, will be stored in R0. Okay, I am using this particular instruction just so that you can understand the working of a macro. Okay, I have already defined a macro called clear register, whose whole purpose is to make my register content, whatever I specify here, as 0. I have loaded R6 value as 4. So as soon as this instruction is executed, R6 will become 0. And the last assembler directive which I have to explain is if else or ENDIF. Okay, so this is very similar to your C program if else. Okay, so what happens, it will check if this particular symbol is greater than 20, but using my assembler directive EQU, I have defined this value is 40. So it will check if 40 is greater than 20, it is true. So this particular statements will be converted into machine codes, while the statements under the else condition will not get converted. That's the purpose of using if else as assembler directive. Okay, it will determine which line of code should be converted to machine codes and which need not be. Now, because this condition is true, what will happen? Argv1 will get the address of initial value, which in our case is the address of this particular statement, and then using this statement we access the actual data, which is 2 all zeros will be loaded into argv1. If this was false, then this was the address loaded in argv1 and we would access its content and place it in argv1 itself. Okay, so the ENDIF finishes this particular if else case. So in our current case, the value which will be loaded will be 2 all zeros into argv1. Okay, now what we are doing is we are using BL, branch with link, followed by calculate sum. Calculate sum, as we have checked before, it is nothing but a symbol we have imported using the import assembler directive. And here what happens is this will make sure a jump happens to this particular code. Along with that, this particular address is stored in link register, so that once that instruction, that is this instruction, is executed, return happens to this particular statement. Now what will happen is this will call this particular code, so a jump will happen to this particular code and addition happens inside this code, that is arg0 is added with arg1 and result is stored in arg0. Followed by that bxlr instruction is executed, which is branch and exchange. What this will do, LR content is updated in PC. Along with doing that, it will check if you have to return to ARM state or thumb state. In this particular case, both codes are in ARM only, so it will return back to ARM state itself. Okay, and these are very simple instructions. I wanted to use this particular label, okay, which points to an uninitialized memory space and store some data there. That's what I'm doing here. arg4 points at this location and we are storing our final result in this location. And stop be stop is nothing but an infinite loop. Okay, so let's see all that happening. First of all, let's check if there are any errors. There are no errors, so I'll go ahead with debugging. Okay, so this is the first line to be executed. Let's see what happens after this. So 2e is the address of byte value and the actual value 12 is loaded into arg0. Here I'm loading r6 as 4 just so that I can show clear register, which is a macro, will reset its value as 0. Okay, I'm using if else here to determine which of the statements will actually be converted into machine instructions. And in our case, because count max we have set it as 40 using EQU, this condition is true, so arg1 will be loaded with value 2 and all zeros. Okay, and next control jumps here and we branch to this particular code. Okay, as you can see, link register is updated with the return address. Okay, so here addition is supposed to happen. Yes, so we got the answer 2 all 0 and 12, and then we are trying to branch back. What will happen with this? LR is updated in PC. Okay, and we have returned to the exact location where we were expecting to return. Okay, so R4 is now pointing at array and str instruction will ensure our result is stored in the memory location pointed by array. Okay, so you can see our desired answer stored in the memory, but it's stored in the reverse order because of Little Indian system. Okay, and now we have entered an infinite loop. Okay, so those were few commonly used assembler directives that you needed to know.